Hi everybody, it's Mrs. Nicolosi. I'm going to be talking to you about solutions today. We're going to focus our discussion on the topics of concentration, molarity, and dilutions. Concentration is a measure of the amount of solute in a given amount of solvent or solution. Depending on the way that you're calculating concentration, you might be looking at the solvent itself separate from the solute, or you may look at the solvent and the solute together, which is how we get the solution. The components of the solution are the two components that we mentioned, the solute and the solvent. The solute is the substance that gets dissolved. So if you're making solutions, often we think about the solute as being the solid substance that's dissolving into a liquid, most likely water. Water is the most common solvent that you would use in making solutions. And the solvent is the substance that does the dissolving, or the dissolving medium. So together, the solute and the solvent equal the solution. Now, the way that we're going to be calculating concentration of solutions is by calculating molarity of a solution. And molarity is defined as the number of moles of solute over the liters or volume of the solution. So the molarity has the units moles per liter. And we symbolize molarity with a capital M. So make sure that you're using the correct symbols when you're representing all of your different variables in these calculations. It's very easy to get mixed up between molarity, capital M, and moles. So make sure that you're mindful of your units. Molarity can be used as a conversion factor, and that's most often how we use it in our calculations. Because it has two units, moles over liters, we can relate those two units to one another and use them as a way to convert from one substance to another or one unit to another in a calculation. Now here's an example of a molarity calculation using the molarity formula. Oftentimes we are given the mass of the solute rather than the moles of the solute because mass is a more practical unit of measurement in the lab. So the example reads, you have 3.5 liters of solution that contains 90 grams of sodium chloride. What is the molarity of the solution? In order to use the molarity formula that we saw on the previous slide, you need to have the units of moles and liters to calculate that molarity. Since we're given a mass rather than moles in this problem, we first have to convert the mass of sodium chloride into moles of sodium chloride. So the given mass of sodium chloride is the 90 grams that you see here. And this conversion factor right here is the molar mass of sodium chloride. So the 58.44 grams comes from the periodic table. We add the masses of sodium and chlorine together, one sodium and one chlorine, and that would give you a total of 58.44 grams. And that's equal to 1 mole of sodium chloride. So then when you do your calculation, grams cancels out, you're left with the unit moles, and you're dividing 90 by 58.44. And that gives you 1.54 moles of sodium chloride. Then from there, you have to take your moles of sodium chloride and divide it by the volume that's given to you in the problem here, 3.5 liters of solution. And that gives you a molarity of 0.44 moles, 0.44 molar sodium chloride. When we refer to the unit for molarity in a calculation, we say that that's the molar value of that number. So 0.44 molar is how that would read. Now, the other main topic that we're going to be discussing in this unit is dilutions. It's important to understand how dilutions occur. A dilution is when you have a known concentration of a substance and you add more, primarily to the volume of that substance, to make a more dilute solution. So a dilution is what we would usually think of as watering down a solution. We make it more dilute and less concentrated. So the formula that we use to calculate the unknown concentration or volume in a dilution calculation would be molarity 1 times volume 1 is equal to molarity 2 times volume 2, or M1V1 equals M2V2. Molarity and volume in this case are indirectly or inversely proportional, and that means when the volume goes up, the concentration goes down, and vice versa. When the volume goes down, the concentration goes up. In our calculation here, in our formula, it does not matter whether the units for volume are in liters or milliliters. So in the previous example, we saw that the units for molarity had to be moles per liter. And that is still true. The units on molarity will be moles per liter. But your volumes can be in liters, milliliters, deciliters. It doesn't matter what unit the volume is in, because the nature of this equation here allows those units to cancel out. So let's take a look at an example of a dilution. An experiment requires the use of 250 milliliters of 1 molar hydrochloric acid to perform a titration to find the unknown concentration of a sodium hydroxide solution. The chemical stockroom has 18 molars HCl available. What volume of 18 molar HCl must be used in order to perform this experiment? So what we know we need a 1 molar solution, and we know we need 250 milliliters of that 1 molar solution. We know that what we have available is the 18 molar solution in the stockroom. What we don't know is how much of the 18 molar solution we're going to use to then water down to 250 milliliters. So, setting up this calculation using the equation M1V1 equals M2V2, 1 molar times 250 milliliters, that's our M1 and our V1, is equal to 18 molar times our unknown volume. And when you do the calculation, rounding to the correct number of significant figures, you would see that you'll need 14 milliliters of this 18 molar solution. And then you would dilute that to a total volume of 250 milliliters to get the 1 molar solution that is required. So those are just 2 examples of the types of problems that you're going to be seeing in this unit. I will be doing another video that shows you how to do some more of the examples on the worksheets that have been provided. Please, as always, email me with any questions, and I hope you guys have a great day, and I'll see you soon.